Okay, I'd like to first of all start by thanking my fellow HSC senior marker Cheryl Ricks and our dedicated, hardworking group of markers. I'm about to do a presentation for Advanced Mathematics, question 23, 26, and 28. So let's have a look at the first question, question 23. I'm sure everybody's familiar with the question and the context that it's in, so I'm not going to go through too much of that. Over on the left-hand side is a sample answer to that particular question where the students needed to work out a base value of B and then work out a time factor for a population increase. So the students that were doing better responses, there's quite a few steps obviously there, it's 4 marks. This one here was a little bit of a surprise to many of the markers. You would have thought that the first 3 or so lines in coming up to pick up B would have been a pretty straightforward one. The better students were able to get it in 2 lines. Some of the other students that were still able to get B made it a little bit more complicated for themselves. They went around and figured out that there was, they might have had something to do with it. They were doing something with logarithms there. So took logs of both sides, brought the 2 down, then they needed to do a change of base on B. So just really overcomplicated their very basic idea of getting B squared equals 4 and solving that out. So using the reference sheet to find the derivative, most of the better responses, students were able to understand that there is help for them on that reference sheet and they're familiar with it. That's when it's not base E. Understanding that a decreasing rate means we need to put a derivative equal to -30 down here. And showing every step, those high-end students, the ones that were performing, getting 4 marks out of 4, were just not skipping any steps. Even something with simple substitution, putting these derivatives in, putting -30 in, and then solving every single step along the way, showed a solid understanding of the algebra involved. Keeping the values in exact form was also another plus for those students that were performing at the high level, getting the 3 and 4 marks out. And they really understood their logarithms very, very well. For those students that needed a little bit more prompting with some of the stuff that they were doing, familiarize themselves with the derivatives on the reference sheet. Similar story to last year. I think there was a base 2 question with a T issue in 2020, and that's similar story to this one. Students were either treating the derivative as base E and coming into problems in that regard, or they were still not using the reference sheet, but managing to get a derivative out of the context of the question where they came to this line where they needed to differentiate the 2 to the power of -t on 10, but they were changing it to e to the power of ln 2 to the -t on 10, and then coming up with the correct derivative out of it, but really, again, not understanding that there is a much easier way to do this if you're able to know what was on the reference sheet and use it really, really well. Showing working out is something that the students need to make sure that they're doing all the time. So we're able to pick up what their thought process is and allocate them the appropriate marks. As soon as they skip steps, where they can quite often make it really difficult to figure out what their train of thought is. So showing all working out is crucial. Having a negative inside a logarithm means a mistake has been made. So this part is that's generally what's going to happen over here when they've got a positive ln, positive 30. So the derivative, quite a few students will be putting positive 30 in amongst that. They'll end up with a negative inside a logarithm, and instead of going back and having to think, why is that negative in there? And maybe that was the reason why, because of the word decreasing. The students didn't go back and check why it was a negative inside the logarithm. They just sort of either crossed it out, realizing, oh, I can't put this on my calculator. But they really, the fact that it's there should ring alarm bells for the students. So, and quite often that they didn't do it, maybe they didn't have time. And this is sort of a connection with that above dot point. Familiarize yourself with the word decreasing rate and the implication that it's going to have in your working out. So having a negative as a derivative. Understand that time can't be negative. It's some students were coming up with a t value and coming up with down the bottom here. You can see that there is a sort of that this is the correct answer, but sometimes the students will come up with a t value from incorrect working and leaving it as a negative time. That in itself, again, gives them a clear indication that there's a problem in the working out. And if they've got time, they should go back and check what was the issue, if they could pick up their mistakes. Making sure you can revise your logarithm laws is an important factor with solving this question. There were some of the weaker students really couldn't get past this step, that when they had 2 to the power of minus t on 10 and they got to a simple fraction, then they messed up in trying to solve logarithms out. Maybe they just solved put log to one side and brought the t down instead of taking logs to both sides. So revising logarithm rules is a crucial thing for them to work through here. Okay, I think that's pretty much it for that question. Going to question 26. This was done fairly well. Most students were able to pick up pretty good marks on this one. Here is a sample answer. This is by no means the only answer here. There's quite a few different versions of this. There was you could use x equals minus b on 2a if you feel like it to get that answer. It's going to get you the same values, or finding the t-intercepts, halving it to find the max. It's equivalent values. So better students were able to find the time and the derivative, understand the question, find the maximum height, basically reproduce what's given to you on that left-hand side as a sample solution, and show clear working out as well as the substitution. That substitution is important for the students for their own benefit, just so they know they show us they know what they're really doing. So that substitution and clear working out for those students who are picking up 2 marks out of this. Some improvement in some of the students' work include being able to read the question carefully and not just stop at the time part to this. So this was really a 2-part question. So if the students picked up the fact that it's worth 2 marks up the top there, really just with doing a derivative and solving for t is not a logical 2-mark answer. So a lot of the students were just stopping at t is equal to 7. Well, I wouldn't say a lot, but some students were. And it was a fairly simple 2-mark question to pick up. So they were losing this part here where they were doing a substitution back into the value for y. Again, in the process of solving, this was, some students were getting to this point knowing that you needed to do a derivative to get a maximum height, and then making a mess of a very simple solving of a linear equation. Some were ending up with t's a negative, straight away alarm bells. But some were just not able to solve this. Some were making t's equal to 70, or just forgetting some very basic linear solving of that type. Showing all working out is, as always, in every question that you do in mathematics. I'm sure the teachers will always stress that to the students, including substitution, just so we can see what they're thinking. This one here, that was an important one, that the students understood the context of the question. That if the ball is being, or the particle is being shot upwards from a point 100 meters above ground level, that your final answer can't be less than 100 meters. So having just a bit of a think about what's happening in the question and where it's starting, where where it's got to go, you got to have an answer that's more than 100 meters. And some of the students didn't quite pick that up in some of the working out. So they might have found t is equal to 7, or they might have found t is equal to a smaller value, but that they might have made a mess of the t is equal to 7 and found a smaller value. Once they've done the substitution back into here, and if you get something that's less than 100, then you really know that there's a problem on your hands there. Read the question carefully, know what it's asking. This one here was some of the students were adding a little bit, adding the 100 to their answer. So some students were going 345 and then adding 100 meters to it. So they were thinking, I'm shooting it vertically upwards from a point 100 meters. There was a plus 100 being put onto that 345 by some of the students. So something to be aware of. Okay, so part B. So this is 26 Part B. Is the question not an overly complicated question, but they were forced to write the answer in a certain form. So obviously leaving it in exact simplified form, or exact form really, is something that they were required to work with. There's variations of this, so it didn't have to be necessarily that value. There are a few other parts to it. There are other values that you could have picked besides -10 square root of 69, but that was the most efficient one, I think. There's other versions of A square root of B. So that's not the only one that the markers were using. So here in better results, students were able to use the quadratic formula correctly. Sounds pretty logical. There were two values for t. They needed to obviously discard the one that's got a positive, sorry, the negative value to it, and only use the positive part. This becomes a lot more obvious when you simplify it down to this value here and not leave it at that point at the top there. So the students really need to make sure that they're using just a positive t value in the calculation. They were able to simplify quadratic expression, which was important in that spot there. So they needed to get down to the a squared of b. So they needed to do some simplifying surds. Keep their answer an exact value was always important in this question. All right, so students' area improvement, as always, showing every step of working out. So that's just going to be basically I'm sure every marker is going to be saying the same thing, showing full working out in all your steps, and don't skip any. This was a little surprising from the markers, that the marker feedback that I was getting from, and what I was marking as well. You would have thought that just doing a straightforward junior school quadratic equation simplification would have been a pretty basic idea, but there were issues with solving a quadratic equation by some students. And some of them didn't put the correct formula in, even though it was once again on the reference sheet. So something to be aware of. And this was, an issue by not using brackets by some students, and depending on how you put this quadratic equation together. If you simplified through by dividing by -5, then it made the brackets a little bit more visible, I guess. So making sure that the students understand solving quadratic equations is an important thing for this particular question. It was surprising how many students managed to make a mess of this. Read the question carefully and understand what form to leave the answer in. That means up the top here is important, rather than just come down to this step here and maybe just go straight into putting everything on your calculator. So it really is asking you to put your answer in exact form where a and b are integers. And again, this is not the only form of the integers that were available or that were used. Know that time can't be negative, so make sure that you've got two versions of time. They need to be able to either, if it's not obvious which is the negative time, they should really be putting both versions on the calculator to know which one is the negative time and discard that. So we're not going to use negative time, we're only going to use the positive value to it. Know what is meant by the particle hitting the ground and how to find the relevant value. So this was a little bit confusing with the students where it had this word immediately before it hits the ground. So some of the students were taking a little bit of there's your time factor there. So whatever that was in seconds, they were taking maybe half a second off, or maybe taking 1 second off because they were getting confused with this idea of immediately before it hits the ground. And some students just didn't quite, they were either able to do that first step and getting a t value, but not knowing what to do with a t, or they were just able to do a derivative, but not know what to do with the derivative and how to find the t value to it. So something to be aware of. And this is what I talked about a little bit earlier about the negative time component. Use your calculator to test for time to see which is the positive value to it and use that particular value. Okay, so that's it for question 26B. There was a bit of a mixture of how the students went in this question. Some were right on the mark and some were able to pick up just 1 mark through it. Here is question 28A. I'll just let you have a look through that. Finding a straight area on this. Again, the issue is going to be that it's not a base E, and some students will be struggling because it's not a base E. So let's go through this. Here is a sample answer to that particular question. It's worth 3 marks. Better results, students were able to use the reference sheet, correctly find integral of base 2. So down the bottom here is what I'm referring to. So it is on the reference sheet. Students were able to use it if they knew it was there. Show all the steps, including the substitution of the limits, is important for those ones that were picking up full marks. So these are all the students that did really, really well. They were showing every one of these dot points. Now, this one here, find the x-intercept efficiently without needing the logarithms. Again, it's very similar to question 23, where you had b squared is equal to 4. There's not much in it in solving. 2 to the power of x is equal to 8. Quite often, there were students who were, again, knowing that it's got something to do with a logarithm, so taking logs of both sides, bringing the x down, nothing wrong with it. They were getting the 3 out of it. Some were taking, at least half a dozen, maybe 10 lines to get this out. They were doing it correctly, but they were just wasting a lot of time in solving something that was pretty simple to solve. Areas of improvement. So the obvious one is making sure that the students become familiar with the reference sheet and know that there are integrals there, unlike in years gone by, that the reference sheet has anything but base E on it as well. So a lot of the time the students were referring to this as a base E idea and thinking about it as base E idea, which was a problem, knowing that it's actually on the reference sheet. There are other students who were up in this little spot there, 2 to the power of x. Again, these are students that didn't know that there was help on the reference sheet for them to get an integral that wasn't a base E. Just like in question 23, when they were doing a derivative, they were turning this into the integral of e to the ln 2 to the x and going from there. Nothing wrong with it. The students got it out, but again, it wasn't a very efficient way of doing it. So something to be aware of in your teaching practice for those students that are putting e to the power of ln's. If you're going to integrate or differentiate, we don't need to go down that path if it's on the reference sheet. Nothing wrong with it. Again, mathematically it all works fine, but it's just a bit of a waste of time, and it just the more steps that they do, the more chance they have of messing a line up for themselves. So it's something to be conscious of. Understanding solving integrals of base C that are obviously different to base 2. Using brackets as part of your working out of the definite integrals. So the issue with this dot point is not so much of an issue at that front one, that front set of brackets, but obviously with a minus sign in the second set of brackets, it becomes a problem. So if they're not putting brackets in there, some of the times they'll just have a negative part to this, so they won't turn it into a positive. So making sure that the students are putting in the substitution as well as showing clear brackets is important for their improvement in this type of question. Check that the final answer matched the given value. That was a really unusual one that we found with some students, where the answer was given to them. All they had to do was show it. So what tended to happen with some of the students, that second last line, some students would tend to go 8 plus 1 to give you 24 minus 9 over ln2, and then move on from there. They got everything out beautifully without realizing, well, it doesn't match the actual question. So they've got to go back. If there's a show, they've got to go back and have a look at that last step to see, have I got the actual answer that they've given me? So just going back and double checking that they've got the correct answer is important. And some students were confusing this question by doing a bounded by the y-axis attempt, which just went nowhere with them. So that was something that we found and something to be aware of. There were some students, and that wasn't very many, but it was still a little bit unusual to see. The actual question itself, I'll just go back to it very quickly. Some students were interpreting this as a quarter of a circle, and they were doing a let's do, a quarter of the area of a circle. So that's just something to be aware of with that. And there was some students, not many again, but there were some students that were doing this integral up the top here. They were reversing the 0 and 3 and putting a minus sign out the front, and then swapping the 2 and 2 to the power of x and 8. Nothing wrong with the algebra in it, but it just overcomplicates bits and pieces as you go through this. So having a minus sign out the front, factorizing this out wasn't necessary. I think they just wanted the 2 to the x to be at the front of this thing instead of 8. So not sure why they needed to do that, but it was something that was picked up on some of the marking. All right, so the next question, part B. So this bit here, most students were able to pick up some mark out of this. There was 3 steps involved in this. Better students just basically do a clear diagram, large diagram, and showing the correct asymptotes and intercepts, and not going through and adding any unnecessary numbers. So the solution that's on the screen there was just a screenshot of a solution that was on the internet, but on GeoGebra or Desmos. I can't remember which one it was, but the students don't need 5, 10, 15. They don't need 1, 3, blah, blah, all those sorts of numbers that they're not relevant for them. We just wanted to see a 2 as an x-intercept, labeling that asymptote, and the students understood really well what they're doing from that point there. Some students needed to improve deeper understanding of reflections and translations. There's a few steps involved here. So which way do we go? This was a little bit of a tricky one just in terms of marking. Label multiple functions on the one graph, where the students needed to really, if they're going to do one graph and label and draw three separate or two separate graphs, we really need to know which one's which, or even doing three separate graphs, so just so we get an idea what's going on there. So label each one of them so we know which graph you are talking about. Drawing larger diagrams is important, just like the students that did the better responses. Drawing large, clear diagrams, I think every teacher is going to tell you the same thing. Show important features of the required graphs, and by that I just mean we don't need to see 3, 4, 5, 6, 1, 5, all those numbers there, just the relevant features that make this graph important. So the intercepts, and the labeling of the asymptote, so we know what the asymptote is. And can I also remind teachers to remind students that they need to really, if they've got lined numbers on there, which this particular question did on the HSC, they've got actually room for lined responses, that they don't use the lines as just 1, 2, 3, 4, that they actually use the numbers 1, 2, 3, 4. So quite often students will use the lines on the paper as a marker for 1, 2, 3. I'd encourage teachers to make sure that the students don't do that, and just make sure that they label the numbers 1, 2, 3 if they're going to go down that path. Revise understanding of graph transformations is the other key to this question. And lucky last, Part C is, well, this one was done not very well at all. It was only worth 1 mark. So I've given 2 versions of the answer here. There was some, it wasn't common, but there were some students that were able to hit that algebra neatly by rearranging the original equation f of x into the g of x that was required, and going from there. A hell of a lot of work involved for 1 mark, which again really means that they don't understand the concept of that word hence and how it's connected to the previous questions. So better responses, students were able to connect parts A and B to part C and understand the word, the significance of the word hence. So use the information that you found in the previous questions to help you get the answer out of this. So that's where this was good. Students' improvement needed a better understanding of how complex the question is if it's worth 1 mark, and the question only had 3 lines of working out involved. So really going down this sort of a path, going through an integral process, really wasn't going to end well for most students, because they've got to nail it for 1 mark. So something for teachers to take back to the classroom. If it's got 3 lines of working out and it's worth 1 mark, surely this shouldn't be the path that you take, even though you can go down that path. But again, it's all about conserving time in a test. So if you're going to go down that path, it's going to cost you towards the end of the paper. So something, that's all it really needed to do is just take the negative region of part A and you're done. Better knowledge of the word exact value. Again, some students were doing some sort of fudging work involved, but they were coming up with decimal values that weren't exact values. So keeping in mind of the word exact value. So keeping in terms of logarithms. There was students who were just not even attempting this question, so which was a shame. That was worth 1 mark. So it was obviously an unfamiliar question to many, but just trying to get, like, putting some answer down rather than no answer is better than not attempting that question whatsoever. So something to be aware of there. And understanding that this question did not ask for an area. So this value here is actually a negative region, negative concept there, but it's not an area question. So there's no absolute values required on this question. So there's no concept, there's no word area in that integral. So some students were using absolute values when they came up with a word with a negative value for something. And I think that, yep, that takes me to the end of my presentation. What I'd just like to do is just remind teachers, if they could remind students that if they could invest in some pens that don't leak, because marking fudging work is, so marking pens where you got some leaking in it makes it very, very difficult to read what the students are writing. So some quality pens that don't leak would be a godsend there. All right, so that brings me to the end of my presentation. Hope you found it useful in your teaching.